Hi everyone, hope your quiz went well yesterday. Open up to your mixture pages in your notes packets. We're going to talk about those right now. In these problems, what's going to happen is you're going to have two solutions, okay? I'll just do an example here. So two solutions, so it's, imagine two buckets filled with some kind of liquid, okay? If I tell you that this is a 5% solution, then 5% of it, so this is all liquid, 5% is the actual chemical. So let's say it's 5%, I don't know, saline solution, okay? 5% is actually saline. The rest of it, this 95% remaining, that's actually water, okay? So you might have stronger solutions. Maybe there's like a 20% solution, okay? That might be a little bit more saline, right? That would be 20% saline and 80% water, right? So less water, more chemical, okay? This whole thing, this whole bucket right here is called the solution. If you were to mix these two solutions together, right? If you were to mix these two solutions together, you would probably get something, depends on how much you mix, and that's what we're going to be talking about. But if you were to mix these two together, your new solution would have somewhere between 5 and 20% of saline, okay? Because when you mix them together, you get something that ends up kind of in the middle of that, okay? And that's what we're really going to be talking about here. So these equation setups are very similar, as I mentioned. Amount of total solution. So they're going to give you two amounts, or they're not going to give you two amounts. You're going to have to find two amounts. But they're going to give you a total amount, okay? So they're going to ask you to find, how much of one solution, how much of another, but they're going to tell you the total. You add those together, get the total. Go to the quick check real quick before we do that second equation. If you have 13% saline solution, write an expression for the amount of saline in X liters of solution. Well, if I have 13% of saline in X amount, it's going to be 0.13X. Okay, that's going to give me how much saline, or how much of the chemical, is actually in the solution. So my amount of chemical is going to be very similar to investment, percent X plus percent Y. It's kind of a combination of investment and cost quantity problems, where this right here is going to be my total percent, or not total, like amount of chemical, my total amount of chemical, okay? And this kind of goes along with cost quantity in the way of, this is going to be calculated by taking the percent you want in your mixture and multiplying it by the amount you want of your mixture, okay? So it's very similar to cost quantity in that way, where you have to multiply to get that last number. Quick reminder before we keep going, you can pause this video at any time. I'm going to be talking kind of quickly so the video isn't too long, but feel free. That what's nice about the video is you get to pause, you can rewind, so that you can have time to write, have time to absorb, so feel free to do that. So let's look at number 12. Eric Daly, a chemistry teaching assistant, needs 10 liters of a 20% saline solution. So this is the mixture he's looking for, okay, for his 2 p.m. lab class. Unfortunately, right now he only has a 5% and a 25% solution. How much of each should he mix to produce the 20% solution? All right, we always do the same first step. We have to define our variables. Where do we find what our variables are going to be? Right here in the question. How much of each solution should he mix? So if the question asks how much of each solution should he mix, then the answer, the variables, are going to be the amounts of solution he mixes, right? So the amount of, let's call the first one the 5%, the amount of 5% solution, you're going to see me abbreviate it like that, okay? And amount of, our other solution is 25%. Now we know if we mix 5% and a 25%, we're going to get something in the middle. We very well could get 20%, but we have to be careful with how much we actually mix to make sure we get exactly 20% like we want, which is why we're doing this problem. So our first equation is going to be adding up the amounts. X plus y equals, how much does he actually want of the mixture? He wants 10 liters of the mixture, so 10. Okay. Now, this is where the percents come in. This is my chemical. How much saline is actually in the 5% solution? It's 5% of however much there is. So 0.05x plus however much saline is in the 25 solution. So 0.25 of y equals, how much saline is going to be in the new mixture is the question. Well, the new mixture is going to be 20% saline. Okay, the new mixture is going to be 20% saline. We don't just leave that 0.2 because it's 20% of whatever the amount is of the mixture. Well, how much are we making? 10 liters. So it needs to be 0.2 times 10. Very similar to cost quantity, right? All right, I'm going to go through and solve this. So I'm going to isolate that first variable. I'll isolate isolate x. Doesn't matter what you isolate. We'll get the same answer in the end. So if I plug that in, substitute it in, 0.05 times 10 minus y plus 2.5 y equals 2, 0.2 times 10, right? Distribute that 0.05. I'm going to use my calculator, plug that in. 0.05y, plugging into my calculator, of course, y equals 2. So I hope you're following along and writing this down. And then I'm going to 0.5, plug this in my calculator. I'm going to get plus 0.2y equals 2. 0.2y, again plugging in my calculator, subtracting 0.5, and solving for y gives me 7.5. Once I have y, can I find x? I sure can. Plug it into that original equation. X equals 10 minus 7.5. So x equals 2.5. And same way, we have to write our answers in this form with labels. 2.5 what? Liters. And x was our 5% solution. And y was 7.5 liters of our 25% solution. So we just found out that if we take these specific amounts of these different solutions, we're going to get exactly 20%, which is what we wanted. Okay, I'm going to let you guys set up number 13 and solve it, but I'll write down the answers for you. You should get x equals 4, well, okay, I shouldn't say x. I should say, let's see. Yeah, you should get 4.5 ounces of 4% solution and 7.5 ounces of the 12% solution. So I'm going to let you figure that out. When you turn this in, I'm looking for defining the variables. I'm looking for setting up the equations, and I'm looking for all the work to solve it to make sure that you get that answer. Okay. Same thing for number 14. I'm going to let you do that on your own. You should get 7.5 liters of, liters of 40% solution and 7.5 liters as well of a 10% solution. Okay, number 15, I will also let you work on this on your own. One quick thing though about number 15 is it says how much pure Supergrow. How much pure Supergrow? Well, if it's pure, aka it's all the chemical, that percent is technically 100%. Okay, so one of these values for your percents is going to be 100% Meaning, when you go to put it in those decimals, this is going to turn into what? 1. Okay, so one of the coefficients for one of the variables in one of the equations is going to be 1. So that's my hint for that one. The answer for that should be 2, I believe it's 2 ounces of pure and 30 ounces of the 12%. Okay? This right here is a challenge. I'm going to give an extra credit point to whoever can complete this, showing work with an answer. And how many ounces of water, I'll give you one hint. If it's water, that means there's no chemical. That's a 0% solution. Okay? That's my one hint. It's going to be set up a little bit differently than the others, but I'd like to see if anyone can come up with that. So again, 1 extra credit point if you can get that with work. Otherwise, I expect that you should have 13, 14, and 15 all done with work before you leave class today. This document needs to be sent in to the assignment center, and I need to see, like I said, work for all of these. And it needs to be turned in before you leave for class at 12:45. All right? Have a great weekend. Good luck.